Hey there, get ready for a deep dive. We're going microscopic today. Diatoms, ever heard of them?
Tiny algae, right?
You got it. But they have this whole hidden life, a connection to, get this, the clouds.
Really? Okay, how does that even work? I mean, they're, what, microscopic?
That's the wild part. We've been going through all this research, papers, articles, and it turns out these diatoms are like little factories. They're huge in the carbon and sulfur cycles, way more important than people realize.
Photosynthesis, right? Isn't that their thing?
Yeah, but it's the other stuff they're pumping out that has scientists baffled. There's this compound, DMSP, the methylsulfonylpropionate.
Catchy, yeah. What is it?
Basically, it's how these diatoms survive. It's like, imagine being in a super salty environment or blasted by sunlight. It protects them.
Ah, so like a defense mechanism.
Exactly. Osmolalite, antioxidant, all those fancy words. But then things get really crazy. You ever seen pictures from space? Those huge swirls of color in the ocean?
Yeah, like blooms or something, right?
Diatom blooms. Huge gatherings of these little guys, and the more of them there are, well,
The more DMSP, right? So what happens to it?
that's where the bacteria step in. They break it down into DMS, dimethyl sulfide. And that, my friend, is a game changer.
DMS. Okay, why is that so special?
It's a gas. It escapes from the water, goes up, up, up into the atmosphere, like a message from the ocean.
Hold on, you're saying this stuff from algae ends up in the air. What does it do?
Remember those clouds we were talking about? DMS reacts with oxygen, sunlight, bam. Creates these tiny particles, sulfur aerosols.
Aerosols, like what's in a spray can? How do those make clouds?
Not exactly the same, but kinda. See, water vapor needs something to cling to form clouds. These aerosols are like the seeds, the starting point.
So we've got these tiny diatoms releasing a chemical that gets eaten by bacteria, turns into a gas, floats up, and helps make clouds.
It's like a chain reaction, all starting with these microscopic algae.
That's wild. But what does that mean, like, for the bigger picture?
Well, our sources mention something called the Clausen cloud albedo effect.
Sounds complicated.
It's about how clouds reflect sunlight. More clouds, less heat reaching Earth.
So more diatoms, more clouds, cooler planet.
Potentially. But it gets even weirder because diatoms are also linked to ice formation. Ice. Can you believe that? I know, right? It's like, how can something you can barely even see have anything to do with, well, ice?
It's all about those little starting points. Like, think of how a snowflake forms.
You need that, what is it, like a speck of dust or something?
Exactly. Ice crystals. They need something to grab onto, a nucleus. Just being cold isn't enough.
So are you saying diatoms are like those little specks of dust, but for ice in the clouds?
Sort of. There's all this research coming out about the Southern Ocean where they get huge diatom blooms. Imagine a droplet of water way up high, freezing temperature.
And it has like diatom leftovers in it.
Yeah, like pieces of their shells, those silica shells. They act as ice nuclei. Crazy.
Wait, those intricate, beautiful shells we see in pictures, those are the things making ice.
Those are the ones. They've got this perfect surface for the water molecules to attach to start forming the crystal structure.
So it's like scientifically proven. This isn't just a guess.
Oh yeah, they've got molecular models now. You can actually see how it happens.
Wow, okay, so it's real, but how big of a deal is this? We're talking about what? Global cooling, ice caps, that kind of thing?
Well, remember we were talking about the albedo effect, how clouds bounce sunlight back into space.
Right, the Clausen thing.
Yeah, well, ice is way more reflective than water. More ice crystals, more bouncing, less heat.
So more diatoms, more ice, and the planet's like, thanks, gotta cool down a bit.
It's a possibility. It makes you wonder, you know. Are diatoms just doing their thing, or are they, like, part of some bigger system?
A self-regulating system, that's a wild thought. But hold on, because our sources take a sharp turn here. They start talking about cities.
Cities? What do diatoms have to do with cities?
Get this. They're saying we could use diatoms to make it rain in cities. Rain. Like on purpose. Okay, I gotta admit, this sounds kind of crazy. We're gonna control the weather now. With algae.
Not control, maybe nudge things a bit. Think about it. Cities, they have this problem, right?
Too much concrete, not enough rain.
And all that runoff, full of nutrients. What if we use that?
To feed diatoms, is that what you're saying?
Urban wetlands, designed specifically for diatom blooms. We're already building wetlands for filtering. Why not for weather?
So the dirtier the water,
Okay.
the better for the diatoms, the more DMS, the more clouds.
In a nutshell, yeah. But there's a catch. It's not just about having the DMS. It's got to get high enough.
Like up into the atmosphere where it can actually make clouds.
Exactly. We need a way to give it a lift. Think about mountains.
Mountains. We're not going to start building mountains in cities, are we?
No, but we can steal their tricks. The orographic effect, remember? Mountains push air upwards, creates clouds.
Okay, so what? We make, like, giant ramps.
Elevated wetlands. On platforms, rooftops, whatever, the water gets pumped up, diatoms bloom, DMS goes up, clouds form.
And then boom, rain over this city, all thanks to these tiny algae.
It's a wild idea, right? But it just goes to show you, nature has already solved so many of the problems we're facing.
It's like, we just got to pay attention, figure out how to work with it instead of against it.
Exactly. This whole deep dive, it's been about connections, right? Tiny organisms, global impact. We barely even knew about this stuff. And now we're talking about using it to change the world.
It makes you think, what else is out there? What other secrets are we going to uncover? If you're listening, thanks for coming along on this journey with us. Keep asking questions, stay curious. You never know what you might discover. Until next time, keep on diving deep.